Hey guys, welcome to my channel. In today's video, we're going to be talking about dependency injection and what you might not know. First and foremost, what is dependency injection? Dependency injection is a design pattern that helps you to write loose coupled, testable, and maintainable code by removing the responsibility of creating objects from inside the class. Instead, objects are injected from outside. Take these for example. Class A depends on class B. Normally you might want to write something like this, but this makes it tightly coupled. If B changes, A might break. Testing become harder. So this is not a good way to craft your class or your code. So with BI, the dependency, which is B, is injected from outside. So this constructor type of dependency, in which case the dependency is injected from outside by the runtime engine. Class A does not need to create B, it receives it. This makes your code flexible and testable. Java and C# have strong native support for dependency injection. And there are three types of dependency injection. We have constructor injection, which is the most widely used one. We have the setter injection. We have the interface / method injection. Next, we're going to be talking about the dependency injection lifecycle scope. This tells the DI container, which is the dependency injection container, how long the object should live. So for the lifecycle scope, in C# we have add singleton, add scope, and add transient. While in Java, we have singleton, request scope, prototype, and session scope. In Java, singleton is the default, but in C# you need to specify which one you want. Add singleton in C# is similar to singleton in Java, while add scope in C# is similar to request scope in Java. Then add transient in C# is similar to prototype in Java. For singleton is useful when you need one instance for the entire application lifetime, meaning the object is created once the first time and it is reused every time it is needed. So singleton is best for configuration services, login, caching, database connection, but it is not good for services that hold state that changes per request, and also not good when you need different users to have different data. For add scope or request scope, the object is created once per HTTP request. So when users make a request, the object or dependency is created per request and it is reused within that request. So if the object is needed 10 times within a particular request, on the first need it is created, then the remaining 9 it is reused. For session scope, which is peculiar to Java, the object is created per session. The add scope is also good for database context, so it depends on which configuration you want to use. Though for database context, singleton is popularly used because you don't need to start dealing with maxing connection pool, which you might experience with scope, with add scope. Add scope is also good for services tied to single user requests or anything that tracks data per request. Add scope is not good for background tasks or sharing across multiple requests. For add transient or prototype, a new instance is created every time it is requested, which means it is kind of stateless and you can't reuse it at all. So for every time the object is needed, even if it is 100 times, the object is going to be created and injected. So this is best for lightweight stateless services that do simple operation, mappers, formatters, validators, and it is not good for heavy services like database connection and anything that needs memory stability. For an object to be created, memory location needs to be allocated. So every object created or instantiated actually consumes memory. It takes a little bit of time to instantiate an object, which means singleton or add singleton might be slow in the first request, but for subsequent requests, it's going to be fast since the object is not created for subsequent requests. Now, when I mean request in this regard is when the dependency is needed, not an HTTP request, which means at singleton, the object or the dependency created at the beginning exists throughout the life cycle of the application, which in turn consumes memory, whether the application is receiving a read HTTP request or not. The singleton object exists in memory. It is highly recommended that you use singleton for something that is always in use throughout the lifetime of your application. For add scope and request scope, this is like a blend between speed and memory because the object is created per request, and at the end of the request, the object is destroyed. So which means the memory the object is occupying is freed, which means when there is no HTTP request, the dependency object is not existing in memory, unlike the singleton. Then for add transient or prototype, since the object is going to be created at every point of need, it's going to take a little bit of time to instantiate the object, but the beauty of it is when the object is no longer needed, it is destroyed. You have less memory overhead using add transient compared to add singleton. For add singleton, the dependency object exists in memory throughout the lifetime of the application. So, what does this mean? When you're designing your system and you're taking into consideration memory or speed, it actually affects which lifecycle DI you're going to use. So let's look at this example. This is a common architectural problem I see a lot of people do. Now, class A depends on class B, C, and D. Class A has three methods: method A, method B, and method C. The three methods use class B and C, but for class D, only method A, or let's say method A and method B, use only class C. Let's say these three methods are mapped to request URL, HTTP request URL. When the request comes to C, dependency D is also created. Dependency class D is also instantiated whether or not it is needed by method C, which means you're going to be consuming extra memory for something you are not needing. For this, method C should not be part of this class. Instead, create a new class that has solely these two dependencies which method C needs. Meaning, if you have three dependencies, you should make sure that all three methods needs these three dependencies. Least you have an application that have lots of memory leakage, creating dependencies that are not needed. If you find this helpful, don't forget to like, share, and comment. Thank you.